This is a short video to explain the working of a portable VesselCheck demonstration unit. So it comes in a briefcase made of aluminium, so it's nice and sturdy, and I'll show you what's inside. Okay. So the case opens like any other briefcase as such, and if we open up, the key features are the rechargeable battery pack, which will give you several hours, possibly days of continuous use. The VesselCheck ST1 Ultrasonic Processor, which is firing the signals and processing them with an LCD display that we'll look at later. A range of probes to cover various shell thicknesses, and some ultrasonic coupling gel, which we'll need to get the whole system to work. Okay, one other thing, we've got an inductor selector wheel, which we'll talk about a little bit more shortly. There's a cable to recharge the battery with all sorts of adapter fittings, so hopefully no matter where you are, that should work fine. And not pictured here, but there'll be a USB stick from which you're watching this video, and you'll have the software and some other instructions on there. Okay, so on the front of the case we have a flap and a switch here, so if you open the flap as such, a connector will pop out, which is connected to a lead. There's a good 6 or 7 meters of cable there, and I'll just come out to this side. This connector will connect onto any of the probes. So we have a test cell that we're working on today with about 7mm thickness, so we pick whichever's closest. Here we've got the type E probe. On the back it's labelled, saying what the ideal thickness is. For this is 6mm. Right, so straightforward enough. You push the connectors like so. That's locked in there. As mentioned earlier, if we try and connect this without any gel, we're not going to get any signals. I suppose I should power things up before we go any further. So holding down the button on the power supply for 5 seconds, we'll turn it on. If you come in a little closer, you'll see it'll start with a backlight. It's going to tell you what our voltage rating is and what the level of the battery is. Out of the box, everything's set up for 12 volts. The ST1 is configured as so we wouldn't recommend doing any adjustments with the power supply, as I said, because everything's configured to work together. Okay, back to the test cell. So we take the bottle, we have a fairly generous helping of gel on there, like so. And depending on your demonstration, this might be on the bottom of a tank. This test cell is horizontal, as you can see, and we just hold it like so. And you might be able to hear a ticking noise, which is the ultrasonic signal flashing through the inside of the cell. And hopefully before long, we'll start to see a level on the VesselCheck. Okay, so a number's come up there. We'll shortly move on to configuring the ST1. This is represented a percentage height, so that's 39.6% of something. It might be set up for the default 3 meters. Okay, now I've got a bit of tape which I'm hoping is just going to hold that flush so I can carry on. Okay, fantastic. As mentioned, on the USB you'll have computer software which you can load into a computer, and we're going to connect via a 9-way connector here. So if I go this side,
so the second part of this demonstration is to show how the software works and to get the work connected to a computer. Okay, so on the USB there'll be one set of software which you download to your machine. That's located on my desktop here. So once loaded, the ST1 will search for instruments based on its current setup. Now that's come up with a timeout error, and there's a good reason for that. So if we first go to File and Preferences, you may need to switch between RTU and ASCII for your Modbus protocol. This PC uses ASCII. So we click Apply. And there we go. So the configuration is saved within the ST1 processor itself. So as soon as it finds the instrument, it will bring up the configuration settings within the ST1 setup. So as is, this instrument is set up to read in millimeters. It's replicating a 3000 mil or 3 meter height tank, and yeah, the height and volume therefore will match in this instance. You should do things you should look for before you even try to play with the instrument. It's a good idea to save a copy of the configuration onto your computer. So if you get a bit lost, or you think you've made a mistake in your configuration, you can always go back and load up your original setup. So that's quite easy. You click on File and Save. And I might save this on my desktop. And I'll call it PC Portable Demo .st1, and I click Save. There we go in the background. Obviously, you can't open this in any other program. It'll just come out as gibberish. It will only work in conjunction with the ST1 setup software. And likewise, if I go into configuration and I go and change something simple, say for example, I change the low alarm to 300, apply, and exit. Okay, I'm not happy with that. I can't remember what changes I made. I can click on File, Load. And there's the original config file, which we saved just a couple of minutes ago, and we click Open. This will overwrite all existing data but preserve board settings. Great, that's what we're aiming to do. And we click OK. And we'll recall the only thing which I changed was the digital alarms. And there we go, it's changed itself back to 350. Okay, so that's highly recommended before we do anything. Use a copy of the config file. Good. The next thing I'm going to show you is creating a support file. Now, this is particularly handy if there's some diagnostic works needs to be done by us in the head office, and you are required to send us a file with the configuration and field data. So this is fairly simple. In the configuration tab, we go down and click on create a support file, and you'll be met with this dialog box. So login time in seconds. Typically, if the problem is there and in front of you, 5 minutes is enough, 300 seconds, but this can be extended as long as you want, really. Just got a note that you can't use any other aspects of the software while a support file is being created. So we click Start. I'll open the logger, and every few seconds or every second it will log the settings, and it'll do that for 300 seconds or until you abort it, whichever comes first. So save us 5 minutes. I shall abort. Okay, you can see here it's zipping files, and this will automatically save a zip file onto your desktop. It won't ask you where to save it, it'll just dump it there. So if you've got a problem you want us to look at, you would put that as an email attachment, send it into the Canongate office. We'll take a look at it. We take a quick look inside. It will have the parameters, which are all the settings, and things like ultrasonic data, which we read for the period of the log. But don't get too hung up on that. Okay. So now you've powered everything up. We've got to the point where our probe is connected to the test cell. The VesselCheck is switched on. And I can tell you that the display is reading the same as this volume pane here. So it's reading 600 to represent 600 millimeters. All good. Things to look out for. The most, in my opinion, the most useful feature of the software is the digital scope. So if you click on this button, scope, it will bring up a representation. The two axes here, this is time, and this is echoes that are being sensed. So on this particular setting, we haven't got amazing signals, but we've certainly got enough to get by. So this represents an echo hitting the face of the sensor. So this is what we call the ring. This is the pulse of electricity which creates the ultrasonic signal. So that dies off, and then after 831 microseconds, we're sensing a peak. So that's how long it takes, 831 microseconds for an ultrasonic signal to get to the other side of the test cell and bounce back. It'll be the same when you're testing on a tank, but instead of going across a test cell, you're just going up to the interface, the liquid surface. Okay, so it's not too difficult to spot that these major echoes are spaced pretty much equally apart. So after 831, I suppose that should be 1662 ideally. And 2482. So echo 1, echo 2, echo 3. These smaller echoes, if you will, these are, it could be anything. It could be caused by noise. It could be used by the wrong capacitance, inductor selection. There could be a number of reasons. But yeah, if you're not sure what's going on, whether your system's working or not, if you open the scope screen up and you're getting echoes like this, that's a clear indication that things are going well, or they're not. Now, you won't be able to see this, but I'm going to turn the wheel, that inductor wheel, which is located below the battery pack, and just see what effect that has. Okay, so that's gone from 100 to 47, and this is inductance, so these are microhenries, so 100 to 47. Observation there, I think the echoes have got a bit thinner. That's down to 10. There we go. So 10 microhenries just doesn't work with this combination of frequencies. Well, we are getting echoes, but I can guarantee you anything more than a meter and anything other than water, 10 microhenries isn't your inductance value of choice. Okay, let's go the other direction up to 220, see what happens. Okay, this signal is so loud now that, you know, you're bordering on not being able to get distinguishing echoes, and all the way up to 470, which is the maximum. Yeah, we're getting a bit of noise there. So anyway, in the instructions document, there'll be a guide of which inductance value you should use for each of your probe types, but it's an inexact science, so sometimes you can open up your scope and you can go through the inductance values to find which gives you your best results. Okay. Okay, so we shall continue. We'll look at every aspect very quickly. Digital alarms. So you won't have access to these in the demonstration unit, but the ST1 does have alarm puts on the terminal strip. And these are simple volt-free relays, and they're on low and high. So here, for example, high alarm is set at 500 and the volume is 600, so the alarm state will be closed at the moment. And there's a delay feature in there. Typically, these are used to fire bulbs or hooters, safety systems, overfill protection, for example. Okay, user configuration. So, yep, quite self-explanatory, this page. Digital alarms, whether you want them enabled, disabled. 2 choices of analog outputs. However, note, if you're going to change that, there is a jumper setting which requires changing on the board. So don't change that unless you really have to. There's a potential you could cause some damage. Just change it back. Output measurement. We'll go on to show the calibration table. You can have it represented as a percentage height and a percentage volume. Bit of manipulation for this, just to get it to read in millimeters. We'll talk a bit more about that later. And Modbus protocol we already spoke about. That might need to change in order to connect the instrument to your computer. And finally, probe selection. So there's a letter on the back of each of the probes indicating probe thickness, and this should be matched for ideal operation. If you don't, it might work, but this should be, as mentioned, this should be changed to match whatever probe you're using on the test cell. Okay, good. Setup. So the low function. This is a simplification of looking at the digital scope. If you click on locate, it will, or it should give you a height in millimeters and a strength. If I click the locate button, should get it going. It's open, seeing if it makes sense. That's the most simple way to describe it. When you're in the field, like I said, I recommend opening the scope anyway, but if you're going to use the locate function, anything greater than 7 is acceptable. Okay. This is only really used for configuration purposes, so it does tell you your alarm status, things like raw time, so 831 microseconds, which is pretty consistent, etc., etc. Login. This is a simplified version of create a support file. It doesn't. I'll just open it up. It's quite self-explanatory. So it appears as though, yeah, these were the logs taken as part of a support file. So if you want to take some values over a period of time, for example, if you want to leave it unattended and run some tests, that's fine. So setups, there's a few things in there. You can choose which variables to measure, the length of the log file and how it's saved, for example. With this one, you've got a choice of where it actually saves it. So it's quite simple. You click start. It will run for the time in the setup screen or until you click stop. Okay. And once you've stopped it, it will save as a CSV file, which can be opened in Excel. So let's go back to the support file I done earlier. We'll show you what that looks like. Okay, so yeah. In its raw form, this isn't so useful, some of this data. Yeah, these are the main ones, time and height, so you can plot a trend of these if you so wish. Inserts, recommended charts, line graph, there we go. So over that time period, the height didn't change from 600 millimeters, for example. Anyway. That's it from the configuration side. There are some more settings which are accessible. To do this, you need to enter engineering mode. So if we go to preferences and we go from user to engineer. For the time being, we're not going to tell you the engineering password because you shouldn't need it. You'll only need that if there's any problems, in which case you can get in touch and maybe we can solve the problem quite simply for you. The last thing to look at is tank calibration data. So this is a very useful, in fact, it's an essential part of the software, which will convert the shape of a tank into a volume profile. So the most common one by far is horizontal cylinder, for example, LPG cylinders or water tanks. So all these values are in meters, and we're looking at internal dimensions. So don't forget to take off shell thickness if that's what you got on your drawing. And okay, here it's the dimensions of a typical tank: length of 5 meters, diameter of 1 meter, and the dish depth of 0.3 meters. You got the choice to add a decimal point on there or not. Now, if I click calculate table, down the right hand side, this gives you your volume, height to volume profile. So at naught, obviously you got an empty tank, and when we've got 1 meter of liquid, we're 100% full. Now, if I were to click the apply button, which I might have just done, no, I haven't. If I click the apply button, this volume value would change straight away. 600 mil would be roughly, well, it would be 63%. So let's go ahead and do that. Click apply and close. There we go. So the ST1 is tricked into thinking that we're measuring a cylinder of 1 meter diameter now, when it leaves is 63% full. Beg your pardon. Okay. Now, instead of going back and reconfiguring this to measure height, I'm going to load our config file. Okay. Now I've explained the software, we'll pack everything away.
First of all, remove my probes from the tank here. We give this a good wipe with a handy cloth nearby. The XLR connectors, very simple, you push a button and you pull it apart. This slots back into its hole in there. You can unplug the computer cable, you can store this in your office, put it back into the case. And this cable, pushing the black button, should retract back in. Like so. Don't forget to power off. And there we go, that's it.